This is one of the more complicated types of questions you're going to get with definite integration. We're looking at exercise 12C in the book, question 5. It's on page 243. So we'll just work it through step by step and we'll see that it all makes sense. Okay, so the first thing we need to do is find the equation of the tangent to the curve y equals x squared at the point 4, 16. So in order to find out the tangent, we need to know what the gradient is at the point 4, 16, and then we can work out the equation of a straight line through that point. So we differentiate to calculate the gradient at that point. Differentiated, and now we need to sub in when x is 4, is what that's supposed to say. Okay, so when x is 4, dy by dx is 8. So now we know we are looking for a straight line with a gradient of 8, because it's a tangent to this curve, that goes through the point 4, 16. So we can sub this into y equals mx plus c, so we know that 16 equals 8, which is the gradient which we've got from differentiating, multiplied by our x-coordinate, which is 4, plus c, which is currently unknown. That's basically what we're trying to work out. So we know that c is equal to 16 minus 8 times 4, which is 32. So c is equal to minus 16. Therefore, we're answering part A here. Make sure you label it A. So the equation of our straight line, if we put all that together, is y equals 8x minus 16. So for part B of the question, we're asked to sketch the curve y equals x squared and the tangent, which is what we've just found out in part A. In order to do that for the tangent, we're going to need to work out the points where it crosses the axis. So we know that when x is 0, y is minus 16, so we know the y-intercept is minus 16. We also need to know where it crosses the x-axis. So to find out where it crosses the x-axis, we set y is equal to 0. So we've got 0 equals 8x minus 16. So 8x is 16, so x is 2. So we know it crosses the y-axis, the y-intercept at 16, minus 16, sorry, and the x-intercept, as it were, at 2, which helps us sketch this. Right, it's really important that you sketch these two, or the curve and the straight line, accurately, because that's really going to help you work out what area you're looking at. So now we need to sketch our lines accurately. This is the bit you really need to pay attention to. We are asked to consider the area between the curve, i.e. the red line, the tangent, which is the blue line, and the x-axis, which is there. So effectively, the area we're looking at is kind of represented by that green space there. Okay, so now we need to work out, okay, what do we need to integrate to find that area? Just clear that off so we can actually see what we're doing. So if we consider our curve first, the area of the curve which we're interested in is from where it intersects down to there. Okay, and following the curve round. And then what we need to subtract from that, the area we need to take away from that, is the area trapped there and highlighted in blue now. So we take that whole red area and we take away from that the blue area. So now we just need to establish, okay, so what are our key values? So we look on our x-axis and we've got 4 there, 2 there, and 0 there. So when we're looking at our straight line our blue, we're looking between 2 and 4, and when we're looking at our curve, our red line, we're looking between 0 and 4. Okay, the skill here is establishing between what limits we're looking and where the key area is. So it's really important that you draw your sketch accurately. So what we're saying is that our area A is the integral between 4 and 0 of our curve, and take away from that the integral between 4 and 2 of our straight line. Once you've got to this point, the actual integration is reasonably straightforward. Okay, so we do, as per before, integrate it and keep our limits in place. Now we've integrated, we need to pay slightly more attention here because we've got a lower limit of 2, so that means the lower limit is going to have a value, whereas we've just been looking at 0 before, so we need to be particularly careful with our brackets. So now we just need to sub in limits. Pay attention to your brackets at this point. Okay, so now we work out the values of each term, keeping our brackets in place at all times always. Okay, we can see it's getting pretty complicated, so we just need to keep working through term by term. Work that all the way through, we get to 64 over 3. Take away from that 16, which is going to give us 16 over 3 as units squared as our answer. And if we scroll all the way back up, we are showing that the area is equal to 16 over 3, so correct.